about composite functions? F from A to B, G from.
So this is the function F from A to B. Then you have a function G from B to C, and this is the composite function from A to C. G circle F, right? So let me start with few problems on that. So first example 1. Suppose you have ln x, F from R to R, real number to real number, and suppose G is the mapping from real number to real number. Okay, and suppose fx is defined as ln x 0 less than x less than 1 and x square minus 1, x more than equal to 1, and gx is defined as x plus 1, x less than 2, and x square minus 1, x greater equal to 0. Find g of fx, composition of function. Yes, everybody, can you see the question? Ishan? Dipayan?
Yes, sir.
Okay.
Yes, sir.
Okay. You can easily draw these diagrams, right? But you need to write this one, this function, g of fx. So let us write g of fx equal to, what is g is defined? Gx is defined x plus 1 if x less than 2. So x will be replaced by fx, right? Clear? Initially it is clear? Okay. Now you look at that, fx is defined in two ways, 0 to 1 and more than equal to 1. So you have to split that part. So let us split the first part. So I am writing fx equal to ln x, replacing ln x, fx by ln x. So it's gonna be ln x plus 1, x. No, nothing. Everything is given here. Just see the interval. You will have to write the interval. So ln x plus 1, x less than 2, and 0 less than x less than 1. Am I clear? Because you are replacing fx by ln x. So you have to put this condition. And again, this fx can be replaced by x square minus 1 also. X less than 2. Sorry. First you have to write x less than 2. X greater than 1. Clear? Sorry. It should be ln x less than 2 and x square minus 1 less than 2. Now it is fine. Actually, this should be fx. All x should be replaced by fx. This should be fx. Now it is fine. You see, first you are writing g of fx. Then this x, your gx is defined by x plus 1 when x less than 2 and x square minus 1 when x greater equal to 2. So this is gonna be fx plus 1, fx less than 2, replacing all x by fx. So fx square minus 1, fx greater equal to 2. So now this fx should be replaced by this part. So first fx you are replacing by ln x. So this is ln x.
Sir.
Yes.
Sir, how to know where to replace with ln x and where to replace with x square minus 1?
No, I am writing two parts. You have two parts, so you have to replace two parts.
Yes, sir. I'm saying that how do you know that ln x will be the first fx?
No, you can write this one. Actually, ln x is first part, and x square minus is the second part.
Sir, but over there, x square
wait, I have two more parts here. Yeah, it should be categorical. It should be no. Fx is greater equal to 2. You see, fx is greater equal to 2. Your x is replaced by fx. You see this part. So what is your fx here? No, wait. I'm writing this part. First I'm writing this part. Now it is fine. X square minus 1 less than 2. Ln x less than 2 and x square minus 1 less than 2.
Okay, sir. For less than 2 only, we have to replace both the values.
Yes. Clear, Nishan?
Yes, sir. Got it.
Now next, tell me. Now I will replace this part. Tell me. This will be ln x whole square minus 1 ln x and what is next? X square minus 1 whole square. And tell me, is that clear or not? Ishan, Deepayan, is that clear?
Sir, for the previous one, I guess it will be x greater than equals to 1.
Okay. Now you have to repeat. Yes. Now you have to simplify this common region. You are going of the common region. What is the common region in the first case? So let me rub this part. Okay, I'm rubbing this part. This side. I will use this side. This is g of fx, okay? So g of fx could be, what is the first part? Tell me. Ln x plus 1. What is the limit? Limit will be, this is ln x less than 2, that means x less than e square. And 0 less than x less than 1, right? Ln x less than 2, base is e, so x is less than e square. Applying logarithm. X less than e square, 0 less than x less than 1, right? Okay. What about this one? X squared minus 1 plus 1 got cancelled. What is the value here? This is x squared less than equal to 3. Minus root 3 to plus root 3. And this part, this is ln x whole square minus 1. Okay, fine. X greater equal to e squared, right? And 0 less than x less than 1, right? E is a value, E is a number lies between 2 and 3. 2.7 something. And the last part, can you simplify the last? Okay, you can keep it like that also. This is also x square greater equal to 2. So x less than equal to minus root 3 or x greater equal to root 3 and x greater equal to 1. Am I clear with the simplification?
Sir, could you please explain this once more?
This one. What is x square less than 3?
Sir, will you please explain the log once more?
Yeah, wait. If it is more than, then it will this region and this region. That is here. Yes, Ishan, tell me.
Sir, I'm saying that will you please repeat the 2 log 1, 2 log inequality?
First one.
The 2 log inequality.
Oh,
No,
this
sir. This the first and the third.
first and the third. Acha, log x less than 2. So x is
Sir.
less than e square.
Yes, sir.
And 0 less than x less than 1.
Yes, sir. Got it.
And the last part, ln x is greater than 2. So x is greater than e square. Greater than equal to e square.
Okay, sir. Got it.
Now x is less than e square and 0. Okay, let me write a final answer. Now I'm rubbing this part. You want to note down? Please note down. Quickly, you have to copy also these things. Final answer. So g of fx equal to ln x plus 1. What is the common region now in this part? X is less than e square and 0 less than x less than 1. What is the common region? 0 less than x less than 1. Right?
Sir, I
And
couldn't get what you said.
x less than e square. X is 2.7 something, right?
Yes, sir. 2 point something.
And 0 less than x less than 1.
Sir, 0 to 1. Yes, sir.
So this is the common region.
Yes, sir.
I'm taking that part.
So over there, on the previous part, is ln x equal to 4 or 5.
No. So what is the next part? Minus root 3 to root 3 and x greater equal to 1.
Sir, x greater.
Bolo? Tell me, Ishan.
Sir, x greater equals to 1 and lesser equals to root 3.
So 1 to root 3.
Yes, sir.
And what about the next part? Third part? Doesn't exist.
Sir, doesn't exist because it is beyond 2 and it is between 0 and 1.
No common region. What about the last one?
Sir, x greater equals to root 3.
Yeah, that's the final answer. This one, third one. X greater equal to e square. And 0 less than x less than 1. Will there be any common? Yes. 0, 1
and root 1.73.
so greater equal to 1 and 1.732. So what is common? Greater equal to greater equal to 1 to infinity, and it started from root 3 to infinity. So what is it? Am I clear? This last one. This part This part, this part. What is common? This part. This is the only common part. Correct? Clear? It's not difficult, but you have to be very cautious about it. Now you are talking about sketch. Can you draw this sketch? Yes, obviously. These are all simple functions. These are all simple functions. This is a parabola. This is also that kind of quadratic equation, parabola. This is also, you can draw. This is a 4th-degree equation.
Sir, how will be the sketch of the last one look like?
Last one is 1 to the power 4, right?
Yes, sir.
Acha, cubic function. How will you draw cubic function? Quadratic is fine. Quadratic is this type. How will you draw the cubic function?
Yes, sir.
And how will you draw the 4th degree?
Sir, one more down. Okay, sir. Got it.
If you have an even power, both sides is increasing. Odd power, one goes downward, another goes upward. Odd power in case of. You can generalize the concept. Clear, Nishan? If I am clear,
Yes, sir.
so I am giving you one problem for yourself at home, not now. This is example 2. This is 2x, right? In this case, you can find f of gx and g of x using the previous concept. This is for your homework, not now. So I will do one problem right now. Everybody note it?
Sir, just a second, copy.
Can I rub? Let fx be defined on -2 to 2 by fx equal to -1 and gx equal to it's a kind of composition of function because you see you are using mod function. F of mod function. This is also composition of functions. First of all, find out f of mod x. Part by part. Let us start with f of mod x. What it be? -1. All x should be replaced by mod. Clear? Now, is this possible?
No, sir.
So this is not possible. Mod x cannot be negative. So negative value is not possible. And so you are remain with this one. Now this can be two parts, either x positive or x negative. So if x is positive, x minus 1. Yeah, tell me.
Minus x minus 1.
Uh,
Uh, uh, yes, sir. -2 and 0.
okay. What is the definition of mod? This is my actual part. I'm just removing the first part because that doesn't exist. So I will stick to the second part. So after that, I will just split into two parts, positive and negative, and then
Yes, so because in the previous one, negative mod does.
Yeah.
Then you do.
mod x cannot be less than 0. Am I clear?
Yes, sir.
Yes, sir.
Now find mod of fx, the second part. Modulus of fx. Can I of this part?
Yes, sir.
Mod fx. Okay. Mod of -1 will be 1.
Sir, again, the first function won't exist. Sir, again, the first function won't exist.
First function.
Won't exist.
First one.
Yes, sir. -2 to 0 and it is 1. So it won't exist.
No, this function exists. -2 to 0, the functional value is 1. That means the graph will be like this. -2 to 0. This is -2. This is origin. The function will be like this, parallel to x-axis. I'm writing mod fx. I'm taking fx. Fx is given. I'm taking mod. So mod -1, mod x -1. That's it. Whatever it is. Then mod of -1 is 1. Now this one, let me again define mod x -1.
Okay.
Mod x -1 is x -1 when it's greater than 1. And equal to minus of x -1 when it's less than 1. That I'm applying here. Clear, Ishan?
Yes, sir.
Okay. First, now you take the addition of these two functions. What is your gx? This part is done. If I am fine,
Yes, sir.
so gx just check your f mod x and f mod fx. I'm adding. Check. Check the two functions and just simply add. This is a complete analysis, mathematical analysis of the composite function. Okay. Next, I will move to periodic functions. A function f from x to y is said to be a periodic function if there exists, this symbol is there exists, a positive real number t such that for all x, this is the definition of periodic functions, right? Can you give an example of periodic function? Sin x. What is
Sin
it?
x.
Pi by 2. No. That
Sir, 2 pi is its periodicity.
pi. This nature of graph repeats after 2 pi. The same nature will be here. This side also you see. So this is the periodicity. Periodicity means the nature repeats itself. Cos x. Okay. So I will give you some important facts on periodicity so that it will be very helpful to solving problems. Important facts. Number one, if fx is periodic with period t, then afx, then ax of plus minus b. That means any linear combination of the function, any kind of linear combination of the functions. These are real numbers. Is also periodic. I will write number 2. If fx has period t in by n, where in our natural numbers, and co-prime. What do you mean by co-prime? What do you mean by co-prime numbers?
Sir, which are prime among themselves.
Yes, that means 2, 3.
So the common factor is 1.
Common factor is 1, right? And gx has period q equal to r over s. And let T be the LCM of P and Q. That is T equal to LCM of here fraction and LCM. Then T will be the period of F plus G. Provided there doesn't exist a positive number k less than t, for which fx plus gx, else k will be the period. The same rule is applicable for any kind of combination of fx and gx. T will be the LCM of P and Q. So T will be the period of F plus G. If there doesn't exist any number, positive number k, which is less than b. But if it exists, that will be the period. I will give you example of that. Number 3. If fx is periodic with period t, then f of ax plus b. Look at that. This combination is inside the function. A should not be 0. So any kind of multiplication factor is there with x, so your period will be t by mod. Suppose sin x is, what is the period of sin x? 2 pi. So what is the period of sin 2x? 2 pi by 2 pi. What is the period of cos x? 2 pi. What is the period of cos 2x? 2 pi by 2 pi. What is the period of sin x by 2? Sin x is pi at 2 pi. Sin x by 2. Or pi. This rule. Here. And then of the upper part. Something is there? Sin to the power nx, cos to the power nx, sec to the power nx, cosec to the power nx has period 2 pi. If n is odd, has period pi. If n is even. Tan to the power nx, cot to the power nx, period pi, whatever be n. Mod sin x, mod cos x, mod sec x, mod cosec x, tan x cot x. Period pi. But mod sin x, mod cos x, mod tan x. Okay, no, this one is pi by 2. This is the exception. What is the period of mod sin x? Pi. What is the period of mod cos x? Addition of two functions with period, because both the functions are periodic. their periodicity should be pi, because LCM of pi and pi is pi. That should be pi, but it is pi by 2. Why? Because k is more than t. K is more than t. You see that too, property 2. That is why it's pi by 2. Clear?
Sir, can you explain this once again?
Yes. One second, wait, just wait. Can I rub the lower part? Now my question is, what is the period of mod sin x? Pi. What is the period of mod cos x? Pi. So the period of mod sin x and mod cos x should be LCM of pi comma pi. That should be pi. But
Yes,
here it is pi by 2. Why? Because what is property 2? T will be the LCM of P and Q if there doesn't exist any K. But if there exists any K, that will be the LCM. So K here exists a K half. So pi by 2 is the LCM, because in this case you are getting a period with a lower value, with the lesser value than pi. With a lesser value than pi. Otherwise, pi would have been the period. Am I clear now, Deepak?
yeah, understood, sir.
If H. So this is actually property 2. I'm just writing in a different form. Tell me now, more elaborate. So fx and gx are two periodic functions with period t1 and t2. And hs is any kind of linear combination, so I'm taking a simple combination. Fx plus gx. As a period, there are two parts. The period will be LCM of t1 t2. If fx and gx cannot be interchanged by adding a least positive number less than the LCM of t1 t2. But if it is interchanged, just the last example I gave you, mod sin x and mod cos x. What happened if you transform by x plus pi by 2? Sin x changed to cos x changed to sin x. So in that case, the period will be k. So period is pi by 2. The second part. So period will be k if fx and gx can be interchanged by adding a least positive number. Am I clear now? Everyone? Mod sec x, mod cos x, mod tan x, mod cos x, cot x, similar. So you have to be very careful when you are dealing with the mod function. Something else is quadratic is not periodic. Those are non-periodic functions. Exponential non-periodic. Only fractional part of x is periodic. Eight. 8 is simply right. If G is periodic, then F circle G will always be a periodic function. If G is periodic, then composite function is always periodic. Let's give you some problems on this periodicity. Problems on periodic function. If x cosec squared 3x plus cot 4x. See the rules. What is the periodicity of cosec square x? See the rules. You have the rules. You have written the rules. Sin to the power n, cos to the power n, sec to the power n. Pi. If it is an even power pi, check. Have you written that part? 2 pi when n is odd, pi when n is even. Written? But here you have 3. So pi by 3, right? Even power it is 2 pi. For odd power it is 2 pi. But this is even power. Even power it is 5. Yes, and now 3. So there is a rule. F of ax plus b. What is the period of f of ax plus b? T by mod a. So T by 3. And what is the period of this function? Rule is given. Pi by 4. So what is the LCM of pi by 3 and pi by 4? LCM of fraction, LCM of the numerator, HCF of the denominator. 5. Correct? Am I clear? Those are online. Is that clear?
Yes, sir.
3 and 4. Common factor is 1 only. Okay, next. Pi by 3 or 2 pi by 3?
2 by 3 and
Cos x is 2 pi.
2 pi by
So think about that. Yes, what is the answer?
we can write both by root.
If I on Ishan, what is the answer?
2 pi by root 3.
No. Period doesn't exist. 3 is a rational number. Root 3 is an irrational number. You cannot do HCF. No common factor. How can you write the common factor between a irrational number and a rational number? Whatever. If there is a irrational number, period doesn't exist. No common factor. Am I clear? F is not periodic. Yes. You see the rules. Those are the thumb rules. Next. Greatest integer function.
So that's tan pi x by 2.
Pi x by 2. Okay. X minus box x. What is it? What is the diagram for fractional part of x? Correct. Left continuous, but is continuous on the right. So fractional part is actually periodic. See, with periodicity 1. After 1, it will repeat the nature. After 1, it will repeat the nature. And fractional, what is fractional part of it lies between 0 to 1. Always 0 to 1. Look at that. Periodicity 1. So this is kind of fractional part of it. Am I clear? Understood? This is suppose x is replaced by nx plus 1. N. So this is fraction part of x. So this is periodicity 1. What about this one? Tan x. What is the period of tan x? Pi. Pi over pi by 2. So it's gonna be 2. What is the LCM of 1 and 2? 2. So 2 is, please write the explanation. This part. You see nx plus n is y. So this is your y. So what is your y minus box 1? Fractional part of 1. So I have written this. Pi. And you have a multiplication a is pi by 2. So t by a. A, right? Yes. So you see, when I am discussing a topic, not only that topic, I am just relating everything. If there is a graph is relevant, I will connect with that graph. If the functional, some calculation is relevant, I will do that one. So you have to note down whatever you want. Okay, what about this one? And this one. Minus box x. So that's going to be fractional part of x. So that is 1. 1 is the period. If you can find fractional part of x inside the function, the period will be 1. And 2y. So what is the final period? LCM of 1 and 2 pi. Does it exist? Pi is Rational or irrational? No common factor. No common factor. Doesn't have a common one because one is a irrational, another number is rational. Non-period. Yeah, this one. Acha. First note down the question. Look at very carefully. It's a series. Series of trigonometric functions repeating with sine and tan. Okay, let's just first think about the first two terms. So what is the period of sine pi x? 2, right? What is the period of this one?
So pi by 2.
Pi by 2. So it's gonna be 2, right? So LCM of, if I take the first two part, LCM of first two part is 2. What about the LCM of second two part? That means you have to calculate this one and this one. It's gonna be 2 cube, right? Check. Sin x. Question is the question pi? Yeah, it's fine. Huh? The question is pi. Okay, fine, no problem. Okay, no problem. What about the next one? 2 cube. No, pi will get cancelled, huh? What is the period of this one? 2 square. 2 cube. Sorry. Actually, sin x, period of sin x is 2 pi. Period of sin pi x by 2 square. 2 pi over pi by 2 square. So 2 cube. And period of this is also 2 cube. So LCM of this will be 2 cube, right? Final. Last one, 2 to the power n. What is the period of tan x pi? What is the period of, what is the multiplying factor pi by 2 cube? So 2 cube and 2 cube. You do the simplification for yourself, not for the examiner, because it will be MCQ. Okay. I will write few important properties on box and fractional form. Can I wrap this part? Yes, today I will. After this class, after every two lecture, I will give you some assignment from this to solve.
So is this the for n minus
Last one.
is the t b LCM divided by
Ah,
to the n minus
no, for n. L2. First case you have to next to q, next 2 to the power 4, so on. Last one is 2 to the power n. So ultimately the LCM of these 2 to the power n. Maximum is 2 to the power n. Why? N is natural number. What is the domain of greatest integer function? And what is the range? Domain is R, range is set of integers, right? Right? We are talking about these properties. Next is fractional part of x. Already I have drawn the graphs and all that for fractional part of x. So I will write down some